is a noisy event. It begins here, formless at first, in a white-hot flow of molten iron. Thousands of tons of it a day, millions of tons a year. Over half of it from Ford's own blast furnaces and mills, here at the plant on the River Rouge. Iron for engine blocks and crankshafts and other castings. Or moving on for further refining to become steel. Steel that will yield body panels, springs, frames, and many other components. Amid a cascade of sparks, mold after mold receives the molten steel to yield giant ingots for the rolling mills. Through roll after roll in the mill, the ingot is flattened into an increasingly long slab of steel. Final result, coils of sheet steel that can be a mile long or more and weigh as much as 30 tons. End to end, that's over 100,000 miles of steel a year. Amorphous beginnings for another basic material, vinyl, rolled and kneaded like dough in huge mills. Vinyl is used for 721 different automotive parts: crash pads, trim panels, ignition harnesses, vinyl roof coverings, and, of course, upholstery. Ford produces vinyl upholstery in more than 100 different textures, including knitted vinyl, a Ford innovation. The textures, in turn, can take any of hundreds of colors, making possible thousands of fabric designs. The material flows from the plant at a rate of 50 million square yards a year, enough to cover nearly 10,000 football fields. More raw materials, sand, soda, and other minerals, blended together in a fiery furnace to form glass. In the completely enclosed float glass process, the operation is watched by closed-circuit television monitors and operated from the central control room. The glass floats continuously across a bath of molten tin, which imparts its own perfect flatness to the glass and eliminates the need for polishing, all under the watchful electronic eye of the computer. Molten glass emerges as a continuous strip 100 inches wide, 5,000 miles of it a year. The glass is then cut in a variety of shapes for windshields and windows. Laid on an air table with moving guides, windows ride along, supported on a cushion of air from beneath. Encountering a hot, curved surface, they soften to take its form. windshields take on their own complex form when the glass templates are laid on a fixture and heated and respond to the force of gravity. They simply sag into place. Then comes the windshield safety glass sandwich. These windshields are tougher than ever before. They'll give, but if broken, there's less danger of sharp edges. A final inspection for any optical imperfections. Amid flashes from welding equipment, steel joins steel, and basic forms begin to emerge. This is the frame plant, where the structural underpinning of an automobile is assembled. Moving down the line of welders, the frames gradually take shape. Every stage along the way, the product comes under the careful scrutiny of an exacting individual from quality control, whose abiding aim in life seems to be to shut the Ford Motor Company down. And that's the way we want it. And our fault finders can reject anything from a finished frame to a finished automobile, or hundreds of them for that matter. Those that meet approval are shipped to Ford's assembly plant. At the same time, other forms are taking shape under the powerful drive of 3-story high presses, anchored on bedrock and capable of pressures up to 2,000 tons. There are 7 Ford stamping plants, which consume 12 to 13,000 tons of sheet steel a day, turning out doors, hoods, fenders, wheels, bumpers, and other items as though they were bottle caps. Simple forms, like hoods, can be produced in a few operations. But more complex shapes may pass through 9 or 10 presses before the last line of design is expressed in metal. Whatever the form, production is timed to the precise needs of Ford's 21 assembly plants. Here, stampings are assembled and body buildup begins. Automatic welding machines come into play. There are more than 3,500 spot welds in a car, and some of these machines do as many as 130 in 3 minutes. Just as important is the individual welder. Skillful touches all along the way assure a smooth result. The body takes form. And here's that quality control man again, feeling the metal with a special mitt that helps find any surface defects. Checking door alignments, too. Looking for little imperfections a trained eye can spot. Now into a 50,000-gallon red bath, the Ford First, for rust proofing. Particles of primer paint in the solution are electrically charged. The metal of the body bears the opposite charge, and even the tiniest spot draws the protective coating to it like a magnet, literally plating the body with primer. After a second priming coat, the body is sanded and polished and examined again for rough spots. Then on to the final color paint booth. Each painter has hundreds of gallons of different passenger car colors on tap. As bodies take shape, so do engines, beginning with the patterns to form castings. Pattern making is a highly skilled craft, and the patterns must be accurate to 1,000th of an inch. Molds will be formed from patterns for casting engine components. The molds themselves are formed of sand mixed with binding agents to produce a hard, heat-resistant shell. Precision equipment aligns two half shells to form completed molds for engine blocks. Foundries supplying Ford engine plants, molten iron is brought to the casting floor in 2-ton ladles. From these ladles, smaller ladles are filled. Traveling along a monorail, the ladles are brought alongside a slowly moving procession of engine block molds. Optical pyrometer, a foreman on the floor can quickly tell if proper casting temperatures are being maintained. Off the blocks move from the casting floor. Slowly, it seems, but steadily, too. In 5 engine plants, this means 10 to 15,000 blocks a day. As they move along, the expendable molds are broken away from the metal. Once the blocks have cooled, they will be cleaned and sandblasted. Then comes milling and fine finishing, which involves 22 different high-precision machines that perform over 600 operations. In this fully automatic operation, cylinder bores are measured and stamped with the piston size each requires, thereby ensuring proper piston fit throughout the engine. More precision equipment for quality control. This instrument measures the regularity of cylinder bores. The little balls on the glass tube line up, indicating that the bores have assumed the proper roundness and taper. If they don't, the block is rejected. and complex component, the crankshaft. Studs and journals secure the crankshaft in place. Again, that watchful eye. Meanwhile, pistons are receiving piston rings in another fully automatic operation. Then pistons meet blocks. A clamp compresses the rings, and a tap or two drives the piston home. A plastic fork guides the connecting rod onto the crankshaft, and a rod-bearing cap secures it there. Simple check to make sure the engine turns freely. Then additions to the top of the engine, along with a dash of grease, valve springs, push rods, and rocker arms. Now the classic look of the V8 engine pioneered by Ford for mass production in 1932 begins to emerge. We've made 40 million of them since then. A deft touch secures the pan. And if it seems casual, it's only because these men know the required tightness exactly. Finally, a protective coat of paint. And then a roar of light. This is called the hot line. Every Ford engine is run for about 10 minutes before shipment. 45 of them at a time in this plant. Each is checked for oil pressure, vacuum, leaks, noise level, idling smoothness, and, exclusive with Ford, exact engine balance. In one of the most thorough tests of any mass-produced engine made. We move now to the final fusion of everything. The output of frame plants and stamping plants, body lines and paint lines, steel mills and vinyl mills, engine plants and glass plants, all converge on Ford's 21 final assembly plants. There it takes about 19 working hours for a car to be born. In each of these hours, dozens of men will do something to assist its birth. Attach the rear end, mount the engine, add wheels and brakes, secure the body, install seats, and so on. To fill each customer's order, the assembly line is programmed on a computer so that the sub-assemblies feeding components into the line present the exact items specified for each car as it moves along. To keep final assembly flowing smoothly, a 10-story tower is making its appearance in the Ford system. The tower acts as a kind of take-up loop. If parts of the line are moving too fast for other sections up ahead, mechanically completed automobiles can be shunted to the tower for temporary storage. There, automatic elevators tuck them away, 4 to a floor. Each car is accompanied by its identifying punch card. And when a slack occurs on the final line, any of the 40 cars in the tower can be automatically retrieved and returned to the line for final finishing. The trim, upholstery, and other items specified in the customer's original order. The final result is something quite special, provided that man approves. Here on the final line, 1 out of every 10 men is an inspector. And there's a lot to check out. Seats and doors, locks and latches, windows and wipers, radios and heaters, electrical systems and mechanical systems, metal, paint, everything. Now, a new car springs to life. And from here on out, everyone's an inspector. The dynamometer provides a simulated road test to check the engine, transmission, drivetrain, and rear end. Under bright lights that reveal everything, a last close look. Finally, the water test. Here, the car is subjected to a torrential downpour, the equivalent of driving through a hurricane at 70 miles an hour. It must not leak, stall, or short out. If it passes this test, it gets a final seal of approval, with one important exception. A car is born and leaves the assembly plant that gave it birth. With miraculous precision and split-second timing, 15,000 parts have been joined together to form a unique automobile for one American family. A car is born and joins the ceaseless flow of other cars as they leave the assembly plant. Destination? You name it. A car is born. Born of imagination and ingenuity, shaped by technology, fabricated from the raw materials of the earth. These cars are designed to log more than 100,000 miles over the roads of America. Each is prepared for the driving conditions it will encounter there, and the motorist it will serve. American industry uses the moving assembly line to produce a car every 3½ seconds, 24 hours a day, every day of the year.